Hello students, this is a video on the topic tests that we have created for you. Now these topic tests have been created by an intent of helping you to evaluate yourself or your preparation for that topic. So once you have gone through the basic concepts of the topic, practice questions on the topic, these could be tests which will help you determine whether you're prepared with that topic for the exam or not. So give this test once you have done a topic, the concept of the topic. Once you give the test, you can look at this video to get an idea of the kind of attempt that was a good attempt, the kind of time that you should have spent on a question and overall analysis of the test. If you do like the test, there are more than 200 topic tests which are available on our Bodhee Prep Android app. The link for the app is in the description below. So feel free to download the app and make use of the tests. This video is about number systems and the subtopic is properties of numbers. This is test number 1 as per the app. The overall analysis for this test would be, this was, I think, a moderate to slightly difficult level of difficulty test. Good attempt in these tests will be a net 5 to 6 questions correct. And attempt time would go up to maybe 22 to 25 minutes because there were questions where some cases might have been found, which would take some time in getting the answer. Therefore, the attempt time is slightly higher. Looking at the questions, question 1 says, 4 raised to power 7 into 5 raised to power 9 plus 2 raised to power 4 into 7 plus 3 into 5 raised to power 3 plus 2 raised to power 6 into 5 raised to power 8. How many distinct digits? Distinct digits are there in the number. So what I do is I make groups of 2s and 5s. So this becomes 2 raised to power 2 raised to power 7 into 5 raised to power 9. This can be calculated. 2 4s are 16 into 7. This is 3 into 5 cube, which is 125. 2 raised to power 6 into 5 raised to power 8 can be written as 2 raised to power 6 into 5 raised to power 6 into 5 raised to power 8. 5 raised to power 2, sorry. Out of 5 raised to power 8, we've taken 5 raised to power 6 separately, 5 square remains. This further becomes 2 raised to power 14 into 5 raised to power 9, which can be written as 2 raised to power 5 into 2 raised to power 9. Splitting 14 into 5 and 9. 2 into 5 becomes 10. And 2 5s are 32. So this product will be 32 followed by 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. From here we will get 2 into 5 is 10, so 6 zeros and 5 squares are 25. So 1, 2, 3, 4, 5, 6 zeros because of 2 raised to power 6 into 5 raised to power 6 preceded by 25. So this becomes the value for 1, 2, 3, 4, 5, 6. 16 into 7 will be 7 16s are 70 and 42. 112. 3 into 125 will be 375. So we can write it here 112, 375. If we add them, we get 7, 8, 4, 0, 0, 0, 5, 5, 2, 0, 3, 2. So the distinct digits are 2, 3, 2 is repeated, 5, of course, 0, 4, 8, and 7. So 1, 2, 3, 4, 5, 6, 7 distinct digits are there in the product. In terms of level of difficulty, I would say this is a easy question because at the end of the day, all we have to do is make tens and just add, which should not take too much time. Overall attempt time should be around 90 odd seconds. Find the value of 1 plus 1 upon and then kinds of proceeds 2 plus 3 upon 4 plus 5 upon 6 plus 7 upon and so on. So we'll start from the last step here. 8 plus 9 upon 10. Let me write it at the top. 8 plus 9 upon 10 will be 10 8s are 80, 8 10s are 80 plus 9, 89 by 10. 89 by, this becomes 89 by 10. We take the reciprocal, so we get 6 plus 10 goes at the top, 70 upon 89. Now we find out 6 into 89 plus 70. 89 into 6 will be 6 less than 540. 6 less than 540. 4, 5, 534. 534 plus 70 will be 604. So from here, we get 604 by 89 Again, 89 gets cross multiplied, goes to the top, so we get 4 plus 5 into 89 upon 604. 5 into 89 will be 400, 445. So 4 plus 445 upon 604. This becomes 4 into 604. 604 into 4 will be 6 4s are 24, 4 4s are 16. To that, add 445. 50, 61, 2861. So 2861 upon 604. So this entire part is replaced by 2861 upon 604. 604 goes to the numerator then. So this becomes 2 plus 3 into 604 upon 2861. 2861 into 2 will be 2861 into 2 will be 2 into 2. 2, 60, 122, 5722. 12, 5722. 5722 plus 604 into 3. 604 into 3 will be 1812. This becomes 1812 plus 5722 in the numerator. So 4351, 7534. So this becomes 7534 upon 2861. So this entire thing is replaced by 7534 upon 2861. 2861 goes to the top. So finally we are left with 1 plus 2861 upon 7534. That will be nothing but 7534 plus 2861 upon 7534. So 7534 plus 2861 upon 7534, which becomes 4 plus 1, 5, 6 and 3, 9, 5 and 8, 13, 3, carry forward 1, 7 plus 2, 9, 10. 1039 upon 7534. Option A matches the value and that becomes the answer. Now, in terms of level of difficulty, I'd say it's a easy or maybe at best a moderate question because 1, 2, 3, 4, 5 or 6 steps have to be repeated. So there is a chance of a mistake happening. Otherwise, not the concept is not very difficult. It is basic application of fractions, and therefore about 2 minutes should be good enough to answer the question. Let D be a recurring decimal of the form 0.ABABABAB. So A and B are digits that lie between 0 and 9. Further, at most one of them is 0. Which of the following numbers necessarily produce an integer multiplied by D? If D is equal to 0.ABABAB recurring decimal, the P by Q form of this will be AB upon 99. Now, if we want an integer and we want to multiply this by something, we have to multiply it by a number so that 99 cancels out. So if I multiply AB by 99, 99 and 99 cancels out, we get AB, which is an integer in itself. If A is 4, B is 7, this will be 47. The option does not have 99, so we can also have a multiple of 99. For example, 99 into 2 will give us 2 into AB, which will still be an integer. 2 into 99 is 198. Hence, multiplying 198 to D will give us an integer, which will be 2 into AB. In terms of level of difficulty, I would say an easy question because similar questions you would have come across while practicing as well. Basic application of converting a recurring decimal into the P by Q form. A 3-digit number ABC where ABC are distinct digits. Let us mark this. When increased by 33% becomes CAB. When CAB is increased by 33%, it becomes BCA. How many numbers are there? How many such numbers are there? Now, 33.33% means 1/3. So, the original number is ABC, the general form of which will be 100A plus 10B plus C. When this is increased by 1/3, which means the value will become 100A plus 10B plus C into increasing by 1/3 means 1 plus 1 by 3, multiplying the multiplying factor. This becomes CAB. CAB would have a generic form of 100C plus 10A plus B. So this will be 100C plus 10A plus B. 1 plus 1 by 3 becomes 4 by 3. So 100A plus 10B plus C into 4 by 3 is equal to 100C plus 10A plus B. Cross multiplying 400A plus 40B plus 4C is equal to 300C plus 30A plus 3B, which means C is larger here, B is larger here, is 370A, 400 minus 30, plus 40 minus 3, 37B is equal to 300 minus 4, 296C divided by 37, 7 8 is 56, 5, 24. So divided by 37, this will give us 10A plus B is equal to 8C, 74. Now, possible solutions for this equation could be B has to be a multiple of 2 always, because 10A and 8C are multiples of 2. So if B is 2, we could have A as 10, 12, not a multiple of 8, 22, 30. A could be 3, C could be 4, 324. A could be 30, 42, 52, 62, 72. 7, 2 and 9 8 is 72, 4. B could be 4, which means A could be 14, 24. C could be 3, 64, 8, 0, 4. B could be 6, 16, 4, 36, 8, 36, sorry, 56. Difference of 4. And so on. There can be multiple solutions. Let us just stop here and look at the other case. Now, this number, when increased by 1/3, gives us BCA. The generic form of BCA would be 100B plus 10C plus A. So this number 100C, just drawing a line here. 100C plus 10A plus B, the second number, increased by 1/3 means multiplying by 4/3, like we did in the previous case, will be the new number 100B plus 10C plus A. Cross multiplying 400C plus 40A plus 4B will be 300B plus 30C plus 3A. So this is 370C plus 37A is equal to 296B. Dividing by 37, 10C plus A is equal to 10C plus A is equal to 8B. Again, A has to be a multiple of 2 because this is a multiple of 2, this is a multiple of 2, 8B, 8 and 10. So if A is 2, we could have C as 3 and B as 4. This could be one solution. A is 2. With A2, we could also have B as, this is one solution that we are getting common. If we write all the solutions here, that would be better. So if we continue with the solutions for A, B, C, in the first case, we had reached B2, 4, 6. So B could be 8, 10, 18, 28. C could be 7, 4, 4, 7. Just a second. If B is 8, 0, 8 is possible, 18 is not divisible by 8, 20 to 48. C could be 6, 8, 10s are 88, C could be 11, that is also not possible. B cannot be 0. So, okay, these are the overall solutions for 10A plus B is equal to C, such that A, B, C are single digit numbers and none of them is 0, because each of the number is once in the 100 place, so cannot be 0, cannot be more than 9. B could be, B has to be even in the first equation, 2, 2, 4, 4, 6, 6, 8. These are the solutions possible. In the second case, A has to be even. So if you look at the cases where A is even in the first case, we get 2, 4, 3. We get 6, 4, 8. Now if we put A as 6 here and C as 8, clearly this does not satisfy B. 648. 8 4 are 32. This is not satisfying. So this solution will not be acceptable here. The next solution where A is even is 4. So if we put A as 4, C as 6, 64, 8B. This solution also satisfies. So these two solutions will be common to both the equations, and therefore two numbers are possible. One, when A is 2, B is 4 and C is 3. Second, when A is 4, B is 8 and C is 6. So the numbers for ABC could be 2 ABC, 243 or 486, hence two solutions are possible. In terms of level of difficulty, I would say maybe medium to or moderate to difficult, because cases will have to be formed, and these are the questions end up taking time, and therefore the overall attempt time increases. So unless you're comfortable with linear equations where multiple solutions are possible, go for this question. Otherwise, this can be left in the exam. M raised to power 6 plus n raised to power 6 is a prime number. M and n are distinct integers. They are integers, so they could be negative, 0 or positive. Then what is their sum? Now, if either of m or n is 0, say if m is 0, then this becomes n raised to power 6. N raised to power 6 cannot be prime because it will have factors 1, n, n square, and so on. So m and n cannot be 0. Since m and n are not 0, m raised to power 6 has to be a number which is greater than or equal to 0, because negative raised to power even or positive raised to power even will give us a positive value. Similarly, n raised to power 6 has to be greater than or equal to 0. Now, m raised to power 6 plus n raised to power 6, this is a cube plus b cube, can be written as m square cube plus n square cube. So this becomes m square plus n square. Actually, they are integers. A plus b into a square minus ab plus b square. If I look at m raised to power 6, because we know that m and n cannot be 0, there and their integer values, so minimum value of m has to be -1, or it has to be -1 or less than this number. So we can actually say not just 0, m raised to power 6 and n raised to power 6 will be greater than or equal to 1, not just 0. Or rather, m square and n square will be greater than or equal to 1, because apart from 0, any integer that they take, 1, 2, 3, 4, 5, -1, -2, -3, -4, when we square the number, it will be a number which is 1 or greater, because m and n are integers. And therefore, we can be sure that m square plus n square will be greater than or equal to 2. Now, if we look at this product here, and we want m6 raised to power n6 to be prime, one of these numbers has to be 1, because a prime number can be written only as 1 into n. There is no other factor. Now, m square plus n square cannot be 1, because m square is at least 1, n square is at least 1, so m square plus n square cannot be 1, and therefore m4 minus m square n square plus n4 has to be equal to 1 for m raised to power 6 plus n raised to power 6 to be prime. Now, from here we can write the sum. If we add or subtract m square, n square on both sides, this is 1. We can put values to get this answer. If one of them becomes 1, 0, or if we try to complete the square, let's do that. We subtract m square, n square on both sides. So m raised to power 4 minus 2 m square, n square plus m raised to power 4 is equal to 1 minus m square, n square. This becomes m square minus n square whole square. This is equal to 1 minus m square n square. Now, the left hand side is a square. So it has to be either 0 or 1, because right hand side is 1 minus m square n square. 1 minus m square n square will be 1 minus m square n square has to be less than equal to 1, and we know that m square minus n square whole square has to be greater than equal to 0. Also, m square and n square are not, they can be 1, are not 0, therefore it can be 1. This will be 0. One minus m square n square, the right hand side has to be non-negative. It can either be 0 or positive, because left hand side is a square, so it will not be negative. 1 minus m square n square cannot be 1, because we know that m and n are not 0. This is something that we figured out in the first step. So 1 minus m square n square cannot be 1, because m and n are not 0. Therefore, 1 minus n square n square has to be equal to 0, which means m square n square has to be equal to 1, which means m into n, or we can say m square minus n square, m square minus n square whole square will also be equal to 0, which means m square is equal to n square. But m and n are not equal, and therefore if we combine these two, where we know that m square n square is equal to 1 and m square is equal to n square, the only possibility is that m becomes 1, n becomes minus 1, or m becomes minus 1, n becomes 1. In both these cases, m square n square will be 1 and m square will be equal to n square, and therefore this equality will hold. So these are the two solutions possible, and therefore we have to find their sum. The sum of m plus n in both cases will be 0, 1 minus 1, and therefore the required sum is 0. So this could be one approach. The other is m6 plus n6 is prime and they're distinct numbers. M and n, we can again start to put values and check. If m is even, n has to be odd, but then the number will be very big. I think making one case, for example, trying to put m raised to power 6 plus n raised to power 6 to equal to the smallest prime, we can get the values of 1 and minus 1, and this value satisfies 0, so this has to be the answer. So hit and trial could also be one way of going about the question, but I think overall, I think moderate to high level of difficulty, and actually figuring out the answer might also take time. So yeah, 2.5 to 3 minutes easily to solve this question. P plus 1 by Q is equal to Q plus 1 by R is equal to 1. P, Q are real numbers. What is the value of P, Q, R plus R plus 1 by P? P plus 1 by Q is equal to 1. Multiply the entire thing by Q. PQ plus 1 is equal to Q. Q plus 1 by R is equal to 1. Multiply the entire thing by R. QR plus 1 is equal to R. We try to get PQR plus R. Multiply this by R. PQR plus R is equal to RQ. We also need 1 by P. So from here, we try to get 1 by P. P plus 1 by Q is equal to 1. So P is equal to 1 minus 1 by Q. P is equal to Q minus 1 by Q. Take reciprocal, 1 by P is equal to Q upon Q minus 1. So PQR plus R plus 1 by P. PQR plus R is equal to RQ plus 1 by P is Q upon Q minus 1. Now, if we look at the value of Q minus 1 from here, q plus 1 by r was 1. So 1 by r is equal to 1 minus q. Taking the reciprocal r is equal to 1 upon 1 minus q. So this can be written as rq. We take the negative sign common, minus q upon 1 minus q. If we multiply this negative sign here, we'll get q minus 1. This is nothing but rq minus q into 1 upon 1 minus q, and that we know is r. So rq minus qr, which will be 0. So the value of pqr plus r plus 1 by p eventually will come out to 0. Option C becomes the answer. I think in terms of concept, may not seem difficult, but arranging can become a challenge if you're not able to find the right elements. Otherwise, we'll have to look at each of the term one by one. So we'll find out PQR, then we'll look at R plus 1 by P, which might end up taking time. So I'm saying towards a difficult level of question, 3 minutes to solve the question. 97 by 19 is equal to a plus 1 by b plus 1 by c, where a, b, c are positive integers. What is the sum of a, b, c? Rather than working on with the right hand side, work with the left hand side in such questions always, because we can deal with these numbers. So 97 upon 97 upon 19, I'll try to break it down into this format exactly. We divide 97 by 19. 19 to the 38 and 19 5s are 95. So this becomes 5 plus 2 by 19. 19 5s are 50, 95, 97. This can further be written as 5 plus, taking the reciprocal, 1 upon 19 by 2. Again, divide 2 by 19. The division happens 9 times. 9 to the 18 plus 1 by 2. If we now keep it equal to a plus 1 by b plus 1 by c, we can simply substitute the variable at the same place with the number. A becomes 5, b becomes 9, c becomes 2. Sum of ABC is 5 plus 9 plus 2, which is 16. 5, 9, 14 plus 2, 16. Again, would have come across such questions earlier in life. Therefore, I am saying easy question, 90 odd seconds to complete the question. M is equal to root of 3 minus root 5 plus root of 9 minus 4 root 5. N is root of under root of 7 minus 1 minus root of 11 minus 4 root 7. Whenever we get this kind of a term, under root of a minus a multiple of 2 root c, what we do is we try to express this as a square plus b square plus 2ab or minus 2ab, so that this becomes a plus b whole square and the root cancels out. Now, how do we find a and b? Split the second term. So take out 2 first of all. So we'll be left here with 2 into root 5. One of the terms becomes a, the other becomes b. 2 square plus root 5 square is 9, and therefore those are my a and b. 2 square plus root 5 square minus, so this becomes the term. Root of 9 minus 4 root 5 can be written as 2 square plus root of 5 square minus 2 into 2 root 5. We write this as root 5 minus 2 whole squared. Root 5 greater than 2. And therefore, this overall term becomes root of 3 minus root 5 plus root of root 5 minus 2 whole squared. Since there is an under root, so we're taking the positive value. This will be root of 3 minus root 5. Root and square will cancel out, plus root 5 minus 2. Root 5 cancels. So root of 3 minus 2, which is 1, hence 1. So m becomes 1. We come to n. Again, we operate with the last term first. This can be written as root of 11 minus, take out 2 first for 2ab. So we're left with 2 and root 7. 2 square 4, root 7 square 11, so, which is there already. So this is 2 square plus root of 7 square minus 2 into 2 root 7. Again, because root 7 is greater than 2, we write this as root of 7 minus 2 whole squared. And therefore, if we look at n overall, we'll get root of, again, another root of 7 minus 1 minus root of root 7 minus 2 whole square. This last root and square will cancel out. So we get n as root of root 7 minus 1 minus root 7 plus 2. Minus of root 7 plus 2. Root 7 cancel. Minus 1 plus 2 is 1. So n becomes root of 1, which will be 1. And therefore m minus n upon m plus n, will be nothing but 1 minus 1 upon 1 plus 1, which is 0. 1 plus 1, which is 0. Option A. Level of difficulty, I'd say moderate. 2.5 odd minutes to solve the question, because this is something that you would have come across while doing surds. Once we know it, repetition is easier. N is equal to 2.xxy, xxy, xxy, x. So three repeating terms, where at most one of the digits xy is 0, which of the following numbers, when multiplied by n, necessarily results in an integer. N is equal to 2.xxy, xxy, xxy, and so on. This can be written as 2 plus 0.xxy, xxy, xxy, and so on. Now, if we are writing the P by Q form, this will be n is equal to 2 plus 0.xxy bar can be written as xxy upon 999. We have to multiply n by an integer, by a number, so that it results in an integer. Basically, we want to remove this 999 from the denominator. So we have to multiply it with 999 or a product thereof. 999 into 2 is 1998, which is one of the options. So if we multiply n by 1998, we will get 2 plus xxy upon 999 into 1998. This will be 2 into 1998 plus 999, 1998 cancels, so 2 into xxy. As you can see, there is no denominator, so this becomes an integer. So we have to multiply by 1998. Overall, I'd say easy question, basic conversion of fractions into rational number or decimals into P by Q form. Maybe 1.5 to 2 minutes to solve the question. A is equal to k square minus 1, B is equal to k plus 1 whole square minus 1, where k is a natural number greater than 1. How many prime numbers are there? Prime numbers are by which both A and B are divisible for at least one value of k. Now A can be written as k square minus 1, which is k plus 1 into k minus 1. B can be written as k plus 1 whole square minus 1. This is k square plus k plus 2k plus 1 minus 1, which is k square plus 2k. So A is k plus 1 into k minus 1. B is, from here we can write k into k plus 2. Now, if we look at these four numbers, they are consecutive numbers. For example, if we replace k minus 1 as A, so k becomes A minus 1. K plus 1 will be A minus 1. K is equal to A plus 1, sorry. K minus 1 is equal to K is equal to A plus 1. K plus 1 will be A plus 1 plus 1, which is A plus 2. And K plus 2 will be A plus 3. A plus 1 plus 2. So basically A is K minus 1. A into A plus 2. B is A plus 1 into A plus 3. Hmm? K is A plus 1, K plus 2 is A plus 3. So basically four numbers, 1, 2, 3, 4 consecutive. A and A plus 2, this product is A. A plus 1 and A plus 3, this product is B. Clearly, if A is even, A into A plus 2 will be even, if and therefore A plus 1 into A plus 3 will be odd. If A is odd, then A would be odd, whereas B would be even. So 2 cannot be the common factor. But if we look at four numbers consecutive, suppose if we start with A as 1, 1, 2, 3, 4. K is a natural number greater than 1. But there by which both at least one value of k. So here 1 into 3 and 2 into 4 have nothing in common. If we start with A as 2, 3, 4, 5, again 2 into 4, 3 into 5 will have nothing in common. 3, 4, 5, 6. In this case, 3 into 5, 4 into 6. So when A is equal to 3, which means K will be equal to A plus 1, 4. In this case, capital A will be 3 into 5, capital B will be 4 into 6. They will have 3 as a common factor. So out of these 4 numbers, if the first number is a multiple of 3, the fourth number will also be a multiple of 3. And therefore, first into third, second into fourth, both will be multiples of 3. So for at least one value of k, A and B both will be divisible by 3. How many prime numbers? There is only one prime number 3 which will divide both capital A and capital B for some value of k, because A and B are formed from four consecutive numbers. First and third multiplied is A, second and fourth is B. So if the first number happens to be a multiple of 3, the fourth number will be a multiple of 3 as well, and therefore 3 would be common in both. In terms of level of difficulty, I'd say this is a difficult question to figure out, a unique question in that sense. And once you do figure it out, easily 3 minutes to solve the question. So if you look at the overall level of difficulty of this test, as I said, moderate to difficult-ish level of test, 5 to 6 would be a good attempt in this test. And because 2 or 3 questions we are making cases, attempt time will also be higher, on the higher side. Which are the questions that I would have attempted in this paper always? 1, 2, 3, 5, 7, 9 would be my pick. Would definitely have done this one, just find the value and add. Would have done this because repetitive, but have done such questions earlier. Would have done this because, again, basic formulation of decimal to p by q. This again, because cases were being formed, could have taken a call on this question. Not a question which you would want to do first time in the examination. Or in this case, what I'm saying is, since there was one case which was very, very obvious, 1 and minus 1, therefore I'm saying I would have attempted, not solved the question, but if I put trying to put m raised to power 6 and n raised to power 6 is a prime number, gave me one solution from which I got the answer, so I would have attempted this. Again, would have taken a call on this question because there is a very good chance of getting confused with 1 by q, 1 by p, 1 by r. Again, would have done this every single time because I've done similar questions earlier as well. Unless you have done such a question, cracking it in the exam will be difficult for the first time. Would have done this basic concept. Again, not something that I want to pick up directly in the examination. There are multiple keywords where confusion can happen. And therefore, my attempt would be 1, 2, 3, 5, 7, 9.